Hi, this is Max Zamanian. Max Zamanian. I'm PhD in economics and finance. Here I intend to solve a typical example in basic macroeconomics. That would be an example of a simple Keynesian model. I have other videos in the area of macroeconomics, finance, simple mathematics and statistics needed for these two subjects, economics and finance. So you can look at them. Here we have this problem, Keynesian model. Normally you are given the consumption function, tax function, an import function assigned m, and then you have these so-called exogenous variables, government expenditure, investment, private investment, and export. In such cases, typically you are asked to calculate equilibrium, national income, consumption, budget deficit, which is the difference between government expenditure and taxes, tax revenues, and then net export, the difference between export and import, and also you might be asked to calculate private saving, which is equal to national income minus consumption minus taxes. There are different ways to do it, to at least assign equilibrium. Excuse me, the other way around. I use the circular flow of income method, which gives or identify these three variables as net saving, taxes, and import as withdrawals from the economy. So if this factor payments coming to households, some goes to savings, some goes to taxes, and some to import. So these are withdrawals. And also in the model there are some variables called injection, is investment, government expenditure, and export, that are injections to the economy. And at the equilibrium, withdrawals, W standing for these variables, S plus taxes plus import, is equal to injection, that is J, equal to investment plus government expenditure plus export. So this is at equilibrium. W is equal to J. I try to use this equilibrium condition to drive these items. Okay. From this example, we know that the injections are these: 1156 investment, 683 export, 691 and they will add up to, do the calculation here, we can do it together. $11.56 plus, sorry, 683 plus 691, 2,530. Well, for the withdrawals, I have the tax function and import function. And the S is unknown. So I need to carry out this condition for equilibrium. I need to drive the saving function. We know that the saving function is equal to income, national income, minus consumption, minus taxes. I just set up this equation and then try to replace consumption with the function I have got up here, 150 plus 0.75 of disposal income, which is Y, minus taxes. I can get rid of this T because I only want to have Y by the tax function, which is 0.4 Y. And then this is my consumption function. End of the parentheses. And minus taxes again, instead of T, I replace T with 0.4 Y. So I have only Y's on the right hand side. So this saving will be a function of national income. So now we need to do some simple algebra to sort out these terms. So I start with Y and multiply through this minus. So minus 150 minus 0.75 Y minus 0.4 Y. Then I have this minus 0.4 Y. I just can move it up a little bit. Next, I would like to get rid of this parenthesis. So minus time plus is minus 0.75 Y, and minus time minus is plus, and then we have 0.75 times 0.4, and you can see what that is equal. 0.75 times 0.4, it's 0.3 Y. So this time this is 0.3 Y minus 0.4 Y. Now I can add up all these. I have only one constant, and then add up these terms including Y. This is 0.75. So S equal to minus 150. I write this one first, and then next step I add these together. To add these terms with y, I take the coefficient of each of these terms and add together first. So it's 1 here. Then I have minus 0.75. Then I have plus 0.3. Then I have minus 0.4. And the sum will be plus 0.15 y. This is actually the saving function. Okay. So let us put all items here for the withdrawals on the left hand side. S function we have here minus 150 plus 0.15 y, and then t function is given from here plus 0.4 y, and m function is plus 0.12 y. And according to equilibrium, this must be equal to injection, which is 2530. Well, I don't need these parentheses here. I can just get rid of it. I want to keep all these terms with y on the left hand side and add them up together. And I need to move this to the right hand side, this 150, so I add both sides with 150. So this 150 plus cancel out minus 150. And here I add it to the right hand side. To add these terms, including y, again, we add up the coefficients. So I have 0.15 plus 0.4 plus 0.12. So total, I have 0.67 y on the left hand side. On the right hand side I will have 2530 plus 150 I moved from the left hand side. I will have 2680. To solve the equilibrium y, here you divide both sides with 67. .67. So from here you have, actually this is 1, so you don't need to write it. It's y on the left hand side. And on the right hand side we can divide this 2680 by 0.67. We'll have 4,000. You can frame it nice and clean. This is equilibrium national output. All right. Now we can use this to drive equilibrium level of the other items, for example, consumption. We use this function here, 150 plus 0.75 of disposal income, which is 4,000. The national income minus taxes, that is a function here, 0.4 times 4,000. So actually you see you have only numbers on the right hand side. You just carry out the calculation properly, you will get 1950. Tax function, the same. You have 0.4 times 4,000. You will get 1,600. Import function, 0.12 times 4,000. You get 480. Now you are prepared for calculation of budget deficit, means G minus T, and G government expenditure. We had 1156 minus tax, taxes we had 1,600. So you have a negative number here equal to 444, but that actually means that your taxes is more than government expenditure. That means actually you have a budget surplus of 444. So this is budget surplus. For the net export, you have export given 691, and import you have calculated here 480. You will have net export of 211, and finally you have the saving function or private saving. Use the saving function. We had it here, for example, minus 150 plus 0.15 times equilibrium output, which is 4,000. That would be equal to 450. That is actually all. I can give you some additional question that you could solve for next session, and that is to drive G multiplier. I can do that next session. Thank you very much.